Good day. I am Dr. Jefferson L. Bombasi from Manila, Philippines, and I will present our research entitled Classification of Sugarcane Leaf Diseases Using Deep Learning Algorithms. In the Philippines and throughout the world, sugarcane is regarded as a global commodity. According to the Philippine Council for Agriculture, Aquatic and Natural Resources, the sugarcane industry in the Philippines generates approximately 70 billion pesos or $1.3 billion annually. The sugarcane diseases that can affect more than 90% of sugarcane fields in the Philippines contribute to its low output. This study was designed to fill the knowledge and research gaps on sugarcane cultivation in the Philippines. The objective of this research is to classify sugarcane leaf diseases using four major deep learning algorithms, which are VGG16, ResNet V2-152, AlexNet, and InceptionV4. For our research method, we group our dataset into three. First, 70% of our dataset was used for training using the four deep learning algorithms. Second, 20% of our dataset was used for validation to determine the accuracy of the training model. And third, 10% of our dataset was used for testing the accuracy of the classification model in an actual testing environment using mobile phone camera. For our dataset, we used five sugarcane leaf diseases and a healthy leaf, which are Cercospora leaf spot, Helmintosporium leaf, rust, red dot, yellow leaf disease, and a healthy leaf. For each class, we used 2,800 images for training for a total of 16,800. We also used 800 images for validation for a total of 4,800. And we also used 400 images each for testing for a total of 2,400 images. We use these hyperparameter settings, which are fundamentals for preparing CNN for image processing and classification for the four deep learning algorithms that we used. For the optimizer, we use Adam for VGG16 and ResNet V2-152 and SGD for AlexNet and InceptionV4. To set the learning rate of the neural network, we use 0.0001 for all models. The momentum value is 0 for VGG16, 0.5 for ResNet V2-152 and InceptionV4, and 0.9 for AlexNet. The number of epoch is 100 for all models. Batch size is 64 for VGG16 and 32 for the other three, which are ResNet V2-152, AlexNet, and InceptionV4. And for the hidden units, we use 256, 256 for VGG16 and ResNet V2-152, and 128 for AlexNet and InceptionV4. For this study, we use Keras and TensorFlow APIs for the model training. The images were stored in a cloud database for easier access. We have used the Jupyter Notebook software to implement these two APIs for model training, validation, and testing tasks. To evaluate our model, we get the accuracy and the F1 score. So for the results, we obtained an accuracy of 98.31 for Cercospora leaf spot, 98.52 for Helminthospermum leaf, 98.45 for rust, 98.31 for red dot, 98.67 for yellow leaf disease, and 99.31 for healthy leaf under VGG16. For ResNet V2-152, we obtained an accuracy of 98.89 for Cercospora leaf, 99.12 for Helminthospermum, 98.63 for rust, 98.36 for red dot, 98.31 for yellow leaf, and 98.56 for healthy leaf. Under AlexNet, we obtained an accuracy of 97.69 for Cercospora, 98.57 for Helminthospermum, 99.31 for rust, 98.73 for red dot, 99.21 for yellow leaf, and 99.78 for healthy leaf. And lastly, for Inception V4, we obtained an accuracy of 99.36 for Cercospora, 99.65 for Helminthospermum, 99.61 for rust, 99.38 for red dot, 99.31 for yellow leaf, and 99.89 for healthy leaf. For model validation, we obtained an accuracy of 99.31 for Cercospora leaf, 96.78 for Helminthospermum, 99.32 for rust, 99.76 for red dot, 99.79 for yellow leaf, and 99.52 for healthy leaf under VGG16. For ResNet V2-152, we obtained an accuracy of 99.12 for Cercospora, 99.21 for Helminthospermum, 99.38 for rust, 99.46 for red dot, 99.53 for yellow leaf, and 99.51 for healthy leaf. Under AlexNet, we obtained an accuracy of 99.31 for Cercospora, 99.39 for Helminthospermum, 99.28 for rust, 99.36 for red dot, 99.39 for yellow leaf, and 99.76 for healthy leaf. And under Inception V4, we obtained an accuracy of 99.67 for Cercospora, 99.58 for Helminthospermum, 99.81 for rust, 99.47 for red dot, 99.59 for yellow leaf, and 99.53 for healthy leaf. And for model testing, under VGG16, we obtained an accuracy of 99.35 for Cercospora, 96.44 for Helminthospermum, 99.57 for rust, 99.39 for red dot, 99.49 for yellow leaf, and 99.48 for healthy leaf. Under ResNet V2-152, we obtained an accuracy of 99.45 for Cercospora, 99.78 for Helminthospermum, 99.81 for rust, 99.82 for red dot, 99.68 for yellow leaf, and 99.54 for healthy leaf. Under AlexNet, we obtained an accuracy of 99.31 for Cercospora, 99.39 for Helminthospermum, 99.28 for rust, 99.36 for red dot, 99.39 for yellow leaf, and 99.76 for healthy leaf. Under Inception V4, we obtained an accuracy of 99.71 for Cercospora, 99.67 for Helminthospermum, 99.78 for rust, 99.59 for red dot, 99.75 for yellow leaf, and 99.68 for healthy leaf. To compare with other studies, with an average of the accuracy, for Malik et al., they obtained 93.4. For Hemalata et al., they obtained 96 accuracy. For Militante et al., they obtained 95.23 accuracy. For Saavedra Burbano et al., they obtained 90. And our work obtained an average of 99.24 accuracy. For the conclusion, this study demonstrates the use of deep learning algorithms to classify sugarcane leaf diseases. Results show that models perform an overall average of 99.24 accuracy. So among of all the four deep learning algorithms that we used, Inception V4 based model attained the highest accuracy of 99.53 at training, 99.61 in validation, and 99.70 in testing activities. Hence, this study confirms that deep learning based models have been useful in classification tasks of sugarcane leaf diseases. Thank you.